remove parentheses, exponents, etc. We're going to add something to that. We're going to add to that clearing fractions or decimals. So on that step 2, where I had the etc. in there, I want you to put clear fractions and or decimals. Clear fractions or decimals. So look at this right here. Let's go through the steps, and I'm going to help you out on this one, all right? I'm going to distribute through first. I'm going to remove the parentheses, just like we were doing in the previous problems. So I'm going to multiply here and here, and then I'm going to go here and here. So distribution. Get 4, take away. What's that going to be? What's negative 1/3 times 2? So you're doing like 1/3 times 2, right? So 2 over 1. So you just go straight across and you just get 2 over 3. So this is going to be minus 2/3. And then when you do here to here, it's a minus and a minus being multiplied together. So you should get a plus 7 over 3. And you'll want to put 7 over 3 with the x attached to it. And then now I can move to the other side of the equation. I've got 2x minus 2. So are there any questions on that part right there? Everyone understand where that 3 comes from on the bottom there? Okay, at this point I am going to choose to clear fractions. You don't have to do this step, but it helps you because it gets rid of the fractions. So you're always allowed with an equation to add or subtract the same thing from both sides, or you can multiply or divide both sides by the same number. I am going to choose right now to multiply both sides of this equation by a number. What number do you think I'm going to multiply by? 3. So what I'm doing is I'm looking at the denominators, and I'm looking at all fractions, and I only have these 2. I'm looking at these numbers, and I'm trying to find a common denominator, or a least common multiple, which is 3. And I'm going to multiply everything by 3. Everything. Both sides. So at this point, I'm going to multiply this side by 3 and multiply this side by 3. Now, what I'm saying is this is still the same. You're going to get the same solutions because whatever you're doing to one side, you're doing to the other side. And maybe it's not clear why I'm doing this right now, but let's just follow the problem through, okay? Just follow me through this. I now need to distribute this to here, which would give me what? 12. And then this to here. What would happen there if I take 3 times 2 over 3? So this is like 3 over 1, and these 3's cancel, and you'd be left with 2, wouldn't you? So the whole idea here is that by multiplying by 3 here, you would get like 6 over 3. You could look at it that way. 6 over 3 is 2. But at the end of the day, the 3 and the 3 cancel, don't they? So I just have minus 2 here. And then what would the next piece be? It'd be plus, right? Plus what? 21 over 3, which is 7, right? The 3's would cancel again. So you're just getting 7 what? 7x. What have I done here? I mean, can you tell what I've done? By coming in and hitting this all with a 3, can you tell what I've done? Distributive, but notice there's no fractions anymore, right? It's going to be much easier to work with. Okay? And now on the other side, the 3 has to go through. Now I'm distributing, but I'm distributing backwards. You're allowed to do that. You can go this way. So distribute, and you get what there? 6x minus 6. Okay. So clearing fractions is just to make your life easier, all right? So you don't have to work with fractions. Does anyone have any questions over that step? Because I see some looks of confusion or disgust or something. You sure? I keep going, right? What would be our next step, Christian? Where's Christian? What would be your next step at this point after you've cleared the fractions out?
Well, I'm going to subtract the 2 to the 12 first.
Okay, so you're going to put these together. So we call that collecting like terms, right? You're going to put those together. That's going to give you 10. I'm going to go ahead and do that over here. We have 10 plus 2x. Keep going, Christian. What would you like to do
And
next?
I'll subtract the 10 to the opposite side, to the 6.
Okay, so you're going to try and get your x's on the left side, so you're deciding to subtract 10 here, which means you have to subtract 10 here.
To the 6, negative 16.
So get rid of the 6x, so you're going to subtract 6x
Yes.
and subtract 6x. Okay, so that'll get these to cancel, that'll get that to cancel. So Christian, what would you have left here when you're
X will equal negative 16.
x will be equal to negative 6, take away 10, negative 16. There you go. Questions? Let's look at those two. They look weird, but they're not that bad. They just look a little weird. Before I do numbers 26, let me make sure we all understand a property of fractions. Are you all clear with this idea? Okay, you see that right there? We all realize that this is 5 over 6, right? That's not what I'm trying to get at here, right? That's 5 over 6. But I'm asking you, is this also 3 over 6 plus 2 over 6? Yes? So I can take that number, put it over 6, and then put the plus sign between them, and then put that number over 6. These two are the same. So in other words, I've split it into two fractions. That is allowed because if I asked you to go from here back to here, right, that would be common denominator, add these together, and you'd be back here, right? So you can go from here to here or here to here. And that is a property I'm about to use. Does it work the other way around? Can you split this up into 6 over 3 plus 6 over 2? I mean, you can do it this way, right? Two things on top being added, you can split it up into 2. But if you flip it over, are you allowed to do the same thing? No? Yeah, because look, this is really 6 over 5, right? 6 over 5? Which if you do that in your calculator, you get like 1.2. Here, what is this? What's 6 divided by 3? 2 plus 6 divided by 2. If this went to this, then you're saying that that's equal to 5, right? That's not 5 though, it's 6 over 5. So this from here to here is not allowed. This from here to here is allowed, all right? So just be careful on that. So let's do number 26. 4x plus 9 over 3 equals x. All right, this is a linear equation. Right, David? Where's David? Is this a linear equation, you think, David? Yes. It has equation, has x raised to the first power. All right, David, this one we haven't really done anything like this, so I'm just going to ask you to take a swing at it here. Any ideas of what you'd like to do with this? You want to distribute? Okay, yeah. Y'all want to do that? There's nothing wrong with that. Let's distribute the 4 through, so we get 4x plus 36. All of that divided by 3 equals x. All right, David, I'm putting the pressure on you now. Yeah, what do you mean? But like what I just did a second ago? Like both sides by 3? Yeah, let's do that. Do y'all see that? We have this equation here, but we have this fraction. It'd be nice if this 3 wasn't here. And so we're going to multiply both sides by 3. Just so happens that this is the same thing we multiplied by earlier, but this could very well have been like a 5, and then we'd be multiplying both sides by 5. So I'm going to go ahead and multiply by 3 here. But I'm really kind of curious what happens next because I'm a little bit scared about how y'all are going to handle that. David, I'm going to cut you loose here, and I'm going to go with Tanisha, is that right? All right, Tanisha, you get to take over where David was there. Are you okay with what he's doing? Like, you're all right with that? Okay, so if you're going off of this, what would happen now? So you want to do 3 here and 3 here? That is perfectly fine. You're allowed to do that, all right? And I will do that because that's what you want to do. I personally would just cancel the 3s because that's what's going to happen. That's the reason we put the 3 there, is because we know these would reduce out, okay? But I'm going to show you that doing the distribution, we're going to get the same answer, all right? So I'm going to distribute through, or Tanisha's going to distribute through. What would you get here? 12x plus, what is that, 90? What is it? 108. Yeah, 108. You said that, right, didn't you? And then all of that's still over 3, yes? And then equals, the right side, Tanisha, is just 3x. You want to keep going? No? Yes, you do. So remember I put that property up a second ago where I had 2 things over something. I said split it. 12x over 3, good. Plus 108 over 3 equals 3x. And now these 2 fractions are guaranteed to be nice numbers. So like 12 divided by 3 is 4. So this is 4x plus, and then 108 divided by 3 is 36. And that equals 3x. All right? Now, do you see what I mean? When I was over here, Tanisha wanted to distribute it through, which I said was fine. I would have just canceled the 3s or reduced them, because if I just kill this and kill this, what am I left with? 4x plus 36. And that's what we wound up getting at the end, right? So I don't care which way you do it. Just get to it. All right, now Gia. Where's Gia? Hi, Gia. Yeah, what, Gia? At this point. You want to move the 36 over here? And then bring the 3x here? Yes? Is that what you want to do? You seem skeptical. Okay, well, let's make sure we feel confident with it then. At this point, you cannot put these together, right? There's nothing to do on the right-hand side, so now you need all your x's on one side, right? So left side, you want to go left? I don't care. Yes? Okay. So that means you leave this x here. You need this x, 3x, to come over. So since it's being added, you're going to subtract it, right? So subtract 3x, subtract 3x. Now when we do that, we're still going to have a 36 over here. So you had said, let's move the 36 over. How would you move the 36 to the other side? Subtracting it, right? Opposite of whatever's there. Subtract 36. There's nothing to subtract it from. So this is going to cancel. Reduce, or those will cancel, yes. And then let's keep going, Gia. What is left on the left-hand side? Just what? Just 1x. So just x or 1x, and then this was gone, equals, what about the right-hand side? Negative 36. There we go. Is everyone okay with that? Any questions? Okay. So I don't think we'll do it because we're getting to be about the break time here. Luke? Where's Luke? Where?
Back here.
Oh, there you are. How you doing?
I'm good. How are you?
I'm doing good. Luke, on this one right here, just to get us started, do you have an idea of what you'd want to do on that one?
Yes.
Okay. What would you do to start that one?
Subtract 6/11 from that side.
So you're just going to go after getting x by itself right now. Just bring it over. Okay, I'll do it. Let's go ahead and do it. That's not what I was going to do, but you know what, Luke? The great thing about math is as long as you don't break any rules and you do all the steps correctly, you should get the same answer I get. All right, so let's go ahead and stick with what Luke's doing here. Luke noticed that the x is already almost ready to be by itself, right? It's almost by itself. So he's just going to subtract that from both sides. Yeah? So when you subtract 6 over 11 here and subtract 6 over 11 here, this is a little bit weird because the numbers aren't as nice, right? These cancel. Luke, what are you left with on the left side?
You're going to be left with 7,
On the left side.
X.
Just x, right? And then equals, now how do you plan on doing this? 11 over 7. Yeah, okay, so you are going to do that really, right? So now you're going to find a common denominator. Which in this case would be what? 77 would be your common denominator. So you have to turn both of those into 77s on the bottom. So you multiply the top and bottom of this one by 11 and the top and bottom of this one by 7. So I'm not going to show that work necessarily. You should get 121 over 77 minus 742 over 77. Everyone okay with that? 7 here and here, 11 here and here. And then we'll be done. 121 take away 42. Is that 79?
Yes,
79 over 77. There we go. Okay, good. Now, Luke, can I show you another way? I mean, we're going to get to the same answer? Okay? All right. And I'm not saying that my way is any better at all. I'm just saying that it's a different way. I look at this linear equation, and I don't like the fractions. So I decide to clear them right to start. Okay? So I look at this, because there aren't any parentheses or anything for me to deal with, so I'm going to go and try and clear the fractions. So I'm going to multiply both sides of the equation by, what do you think? 77, okay? Because 77 is a multiple of both of these. So I'm going to multiply this side by 77 and this side by 77. Y'all with me?
Okay.
Okay, now watch what happens here. If you do this times this, I know it looks weird, but think about what this 77 over 11 would turn into. What would the 77 over 11 turn into? A 7, right? And so this over this would give you a 7, and then you'd have to multiply that by 6, which would give you 42. And then you have to multiply this times this, which would give you 77x. Do y'all follow that?
Okay.
I mean, you could get on your calculator and do 77 times 6, and then divide by 11, and if you do that, you get 42. And then on this side, what do you get? Same thing. Like, think about this, 77 over 7, what does that give you? 11. 11 times 11 gives you 121, right? Now, this is a nice little linear equation. I subtract 42 from both sides. And what do we get here? 77x equals, what's 121 minus 42? We did that earlier, didn't we? 79? We're almost there. At this point, because this is multiplication, I want to get rid of that. I divide both sides by 77. Now, I think Luke's way looks better, doesn't it?
Yeah.
It does look nicer, but this is a different way. And it uses the clearing of the fractions. All right, we're going to take a break, but before we take a break, let's do a quick little non-math thing for a second. Raise your hand if your birthday is in January. Just one? Okay. February? March. Okay, March when? 14? 28th? 12. Okay, March. April? April when? 8th?
29, 11,
17, April. May? June? Hey, all right. June what? 21st.
24th,
24th. Okay. July's up next. Okay, July 7th? 10th? 18th? Oh, August? 4th? 30? 31st for me. September, October, just one, November. November when? 8th? December. It's our last chance. 9th? 10th? 9th. There we go. All right. Do you think that that's improbable?
For someone to have the same birthdays?
Well, not for someone to have the same birthday, but for two people in this class to have the same birthday.
That's crazy.
Does that seem crazy?
Or is that like every class that you have someone?
No. Well, let's finish though. It was December what, 9th? You said 10th, 9th, and then who was? 20. Okay, so let me count how many people there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 7, 8, 9, 20, 1, in a random room of about 30 people, okay? To go, next time you're out, standing somewhere in a group of random people, of 30 people, the probability that two people share a birthday is a flip of a coin. It's about 50-50. A lot of people are like, what? Like, that doesn't seem like that's very likely. But it turns out that it doesn't take a whole lot of people to share two birthdays. It's kind of difficult to show that using probability and statistics, but it's true. And I may be off. It might be 28 people. I don't remember exactly what it was, but I like to do that in my classes because about half of the time, two people have the same birthday. So, worked out. Okay? That's weird, right? Let's take a break. It's 12:20. We're going to come back here, right? Let's come back at 12:30. All right. Ooh, you know what? Give me just 30 seconds. Hey. Okay. Yeah, we'll keep it there. All right. Sorry about that. Okay, so one last thing about linear equations, and I'll let you work on your homework. I know I had a student ask me a question about something like number 40 or number 37. When you see something like this, right, like if I were doing this, I would clear the fractions, but just so you understand, x over 4 is the same as 1/4 times x. So you can write that both ways. So like here, this is like 1/2 x, all right? 1/2 in front of x. I just want you to understand the notation means the same thing. All right, we're going to move on to a new topic. We have quite a bit of material to cover if I'm going to get all this on the first exam. I think the next section will work out pretty quickly. So let's take a look at, we're looking at things called polynomials. So I'm kind of hoping that you are familiar with this. We have a polynomial. Poly means many nomials. A nomial is something like this: 4x, 3x squared, 5ab. All of these things are called monomials, all right, monomials. And so if you have a polynomial, it means you have many monomials. So here we have a monomial, and then here another one. So this is a polynomial and this is a polynomial, and what we want to do is make sure we know how to add and subtract them. So the key to doing this is to understand what like terms are. And I think you kind of have an idea of that from what we did in the linear equations. Like terms have to have the same variable raised to the same power. So for example, when we look in this parenthesis, I cannot put any of those together. I cannot combine any of those because they have the same variable but they are raised to different powers. So I'm kind of stuck at this point, can't touch that. Same thing in here, can't put those together. But I can try and put all of them together with this subtraction. So how do you think I'm going to go about doing that? Distribute again, right? I'm going to want to kind of remove the parentheses. So I want to look at this as being a -1, and I want to distribute that -1 through. Now what about the parentheses out here in this first one? How can I get rid of the parentheses on this first one? Distribute a 1. So, I mean, you need to understand there's a 1 out here, and so the 1 would go through, and essentially the parentheses would just drop. So nothing changes. Yes?
I can't remember, but will that one, that imaginary one always be positive?
If it's not written, if there's no signs there, it's a positive.
Okay.
Yep. So let's take this one and simplify it. 3a plus 2a squared plus 3a cubed. And then I distributed through here, I get a -a minus 2a squared and a plus 3a cubed. So this -1 in front changes the signs of all of these monomials to a negative, negative, and then negative times a negative would give us positive. So is that clear for that first one? And now we collect like terms together. So let's see, let's pick up where we left off. Victor's up. Where's Victor? Okay, Victor, have you seen this before? You somewhat comfortable with it? Okay. So Victor, what could I group together here? What could I collect together?
The 3A,
Okay, 3a gets collected with what?
-A,
Minus a. So these two together, and that becomes what, Victor?
2A,
2a. Okay, what about the next collection here?
2A squared with -2A squared.
And those would
Cancel out.
cancel out, right? Those are gone. So you could put a 0 there, but I'm just going to leave it. And then what about 3a cubed plus 3a cubed would give you
6A.
6a cubed, right? So we have plus 6a cubed. So when we're adding polynomials together or subtracting polynomials, you don't change the letter, right? The letter doesn't change, it's just the number in front, which we call the coefficient. Those are the things that we are working with. We did 3, we took away 1, and that gave us 2a's, right? 3a cubed, add another 3, that gives you 6a cubed. So the power does not change when you add things together. So that's still 1, a to the first, that's still a cubed. All right, what about number 2? Ooh.
I have a question.
Yes, go ahead.
Do you have to write the 6a cubed first because it's like a greater?
Good question. So what's being asked is when we write our answer, do we have to put the 6a cubed in front of the 2a? So do we have to do this? And the answer is no, you don't have to. You can. They're both the same answer. They're both correct. Who said that? Okay, thank you. This is what we call descending order, which means you start with the highest power that you see and then move down. That's a standard way of writing things, but it's not incorrect to write it this way. Okay, so both of these would be sufficient answers. All right, on the second one here, can y'all open the door? Yeah, remember y'all wanted to keep ourselves locked in here, so. All right, so what about on the second one here? Timothy, where's Timothy? Timothy, on the second one, removing the parentheses on the second one, am I going to have to worry about any changing of signs here, Timothy? Like on that one, we had a minus that had to go through, right? Here, do we have a minus that has to go through?
No.
No, we don't, right? So really, this is like a 1 here, and then this is like a 1. So when we distribute and distribute, nothing's going to change, right? Everything's going to stay exactly the same. So we have 3a plus 2a squared plus 3/5 a cubed plus 6a minus 2/5 a squared minus 3a cubed. So nothing changed. All we did was got rid of the parentheses. Now, Timothy, you want to help put things together now? Start with the a's. How many A's will we have?
It's gonna be 9.
9A. So you've got to do 3A and 6A. That gives you 9 A's.
And it's gonna be
Ooh, yeah, right? The A squared's a little bit different, isn't it? Because you actually have a fraction here, right?
I'm gonna get rid of fractions.
How do you mean get rid?
Can you?
Okay, I'm glad you're asking. We cannot get rid of them the way we did in the last problem, or in the last problems we were doing, because this is not a linear equation. This is just an expression that we're given. So we actually have to figure out what those two numbers together are. So what I mean by that is, you know, here you just did 3 plus 6, right? That's how you got 9? So to figure out the A squared coefficient, I need to do positive 2 and take away 2/5. So I'm going to just do that on the side here. Positive 2, take away 2/5. And unfortunately, I have to do some, you know, common denominator, things like that, right? So I would rewrite this as 2 over 1 minus 2 over 5. I get my common denominator, and this would give me 8/5. So I'm going through this quickly because now this is stuff we've already kind of done. Take that, get a fraction, get a common denominator, subtract, and get our fraction. So that is the number that's going to go in front of A squared. Does that all make sense to y'all? Okay. That was for the A squareds. That was this one and this one. And now we have to do the A cubes, which will be this one and this one. So what arithmetic do I need to do over there?
-3 over 1.
-3 over 1 and this together, right?
Yep.
So I can write that different ways. I'm going to write it this way. 3 over 5, and I'm going to take away 3. Right? Does that make sense? And then I'll rewrite the 3 as 3 over 1. Common denominator is 5. So multiply top and bottom here by 5. And what is that? What's 3/5 minus 15/5? Negative 12/5? There we go. We're done. Again, I'm not going to put that in descending order. I'm just going to leave it as it is. Any questions? Okay. I want to do number 4, but I think I'm going to do something else first. I'm going to try and convince you of something. I don't know how this is going to go for you, but let's see. When you see this written down, x plus 2, all of that in parentheses squared, what do you think the most common incorrect answer I get for that is? What do you think the most common incorrect answer that I get for that is from students? X squared plus 4. And that is incorrect. So what did that student just do? They just squared the x, and then they said plus, and they squared the 2 and made it a 4. That's the most common mistake that I see. What do you really have to do this multiplication, or to do this squaring? You have to realize that this means x plus 2 times x plus 2. Right? That's what that means? And then to multiply those two together, you have to do that thing called FOIL. You also remember that thing, FOIL? Okay, so that thing FOIL stood for first, outer, inner, last. So you're going to multiply the first guys in these parentheses together. So what do you get when you multiply the first ones? X times x, x squared. Then you do the outer ones, which are the outside ones. What's x times positive 2? 2x. And then you do the inner ones, which are these two. 2 times x, another 2x. And then you do the last ones, which is this one and this one. 2 times 2 is 4, so you get plus 4. And now you can collect these two together, and you get x squared plus 4x plus 4. This is the correct answer, all right? How many of you, show of hands real quick, have seen this FOIL thing? Right? Do y'all like that? Is that okay? So I want to kind of justify why it is that we have to do this and not this. I'm going to try and see if this makes any sense to you. So before I can show it to you, let's talk about a rectangle. I know it's going to seem weird that I'm talking about a rectangle. If I give you a rectangle, I tell you this side is 5 and this side is 2. Can you tell me what the area of that rectangle is? So how do you find the area of a rectangle? Multiply, right? You multiply the length times the height, or length times width. So the area of this thing is 10, all right? Can we all take that on faith? All right, so now I'm going to do something very strange. I'm going to measure, I'm going to get out my ruler here, okay? I'm going to measure out some distance, and I'm going to call that x, okay? And then on top of that, I'm going to measure another little small piece that's 2. Okay, so here's 2 from here to here. From here to here is x. With me? Okay, just follow this through. Let's see what happens. Now, what I'd like to do is I'd like to take that same measurement, but I'm going to put it up like this. So, like that. From here to here, that's x. And then from here to here, that's 2. Okay, so I took this picture, I just made it go like that. Now, how long is this side right here? How long is that side? It's whatever x is plus 2. How long is this entire side? X plus 2, right? So now let me ask you, what is the area of that right there? What's the entire area? It should be this side times this side, right? So the entire area of that whole thing is that, right? Is this right here. This is the area of the whole thing, isn't it? Yeah?
Yeah.
Okay, now, let's break this thing down. If I go up from here, all the way, and then over like this, the area of this whole thing is the area of this plus this plus this plus this, right? All these pieces together. So what is the area of this piece right here? Just this one. It's x times x, right? So that right there is x squared. Okay. What's the area of this one? So how wide is it? 2. How tall is it? X. So this is 2x. And then what about this one right here? X times 2, so that's 2x. And finally, what's the area of this? 2 times 2, and that's 4. So the total area of this whole thing is this plus this plus this plus this, right? That's this right here. You'll see that? And so when you add those together, you get this. So that is this. You'll see that? If you did it incorrectly, like this, all you did was you took this piece and this piece, but you never accounted for these two pieces. So that's just like a visual way of showing you that you have to FOIL, right? And don't do that. All right, so let's get back and do a couple of more multiplications. How about this? I'm going to make one up. What's x plus 1 times x squared minus 3x plus 4? So here I'm asking you to multiply these. See, I'm not asking you to add or subtract. I want you to multiply those. The problem with this one is that you cannot FOIL. Why can't you FOIL? Why can't you use that little FOIL? You have to have 2 and 2. 2 pieces and 2 pieces. Like the one we just did, it was x plus 2 times x plus 2. You have to have 2 pieces in here, 2 pieces in here. If you have 2 and 2, then you can do FOIL. What if you have 2 pieces, 2 terms, and 3 terms? FOIL goes away, all right? So we need a systematic approach for this. Does anyone know how to do this? Have an idea? No? It's okay if you don't. I'm just asking if anyone does.
Distribute the x and the 1.
Okay, so how do you mean distribute the x and the 1? Like both at the same time?
No, you multiply the x by each of the nomials on the other side and the 1.
And then the 1, exactly. So the procedure for this is that you start with the first one here, and you pass it through. You distribute through to all 3, all right? After you do that, you go to the next one, and you distribute it through, and then you put all those together. So how many different multiplications are we going to have to do here? 6 multiplications. And put them all together. So let's do the first one. From here to here was what? What's x times x squared? X to the third, x cubed. Okay, so what's then x times negative 3x? That's this one. X times negative 3x. Negative 3x squared. And then what is x times 4, positive 4? 4x. Okay, we've done 3 of the 6 multiplications. We keep going. 1 times x squared. 1 times negative 3x. And finally, 1 times 4 is just 4. And at this point, we collect all of our like terms together. So how many x cubes do we have total? Just one of them? How many x squareds?
2.
We have minus 3x squared and plus x squared, so that gives us minus 2x squareds. How about x's? We have a 4x, and we're going to take away a 3x, and that should just leave us with 1x. So I'm just going to put x. And then how about just numbers by themselves? Just plus 4. Okay? You may not realize this, but you know that FOIL that we did a second ago? We actually, FOIL is that same thing. See, look, if you follow that procedure, you would start here, right? And then the first thing you do would be this, right? But isn't that F? First ones? And the next thing you do is do this right here, right? But isn't that the outer ones? And then you'd move to the 2 and you'd go and do that. And isn't that the inner ones? And then you do this times this, and that's the last one. So actually, FOIL is the same thing as this technique, but this technique is more powerful because you can use it all the time. If I had 3 terms and 8 terms, I would just start with the first one, go through, second one, go through, third one, go through. Now, I won't give you anything like that, but I'm just telling you it extends that. It's more powerful than FOIL is, I think. All right, we need to look at the problems here. We have some word problems. So let's see if you can read that. Find a polynomial that represents the area of the shaded figure below. It's not even shaded. It doesn't look shaded on the projector, but it is shaded on the handout or on the packet. So they want you to find a polynomial that represents the area of this shaded region right here. Okay, so it's like a square, but we are taking out a piece. Taking that piece out. And it says that the white square, the one on the inside, is x by x. So it's x wide and x tall. So how can we find the area of this thing? What's that? Go ahead. Whoever.
Well, we multiply the side, the 2x. Is it 2x point?
2x minus 5.
Minus 5, and then 2x. Or, yeah, 2x
Minus 5 again.
Minus 5.
Okay, so if I do that multiplication right there, if I do that, what does that give me? The area of the whole thing, right? That's not what I want though. I want the whole thing, but I want us to take this part out, right? So subtract from that, yeah, subtract from that the area of this, which is x times x. And that's it. So that is a polynomial that represents the area of the shaded region. Now, we would need to finish it up. So we would need to clean this up. We have to actually multiply this out. So what is 2x times 2x? 4x squared. And then this times this would give us negative 10x. Negative 10x again on the inside. And then the last one here would be plus